Now can you all hear me? Now can you all hear me मेरे बच्चा लोग? जल्दी से just confirm कर ले. Right now it is working from my end. Is it fine? Is it fine? Is everything fine? Can you all hear my voice? So how does it sound? Is it beautiful? Yes. Now I hope my voice is there. So who's still having the trouble with the voice issue, please do refresh. Everything is going to be super great. Myara, Pardeep, Sanskar, Anisha, Shweta, Dr. Sahil. Okay, now I'm thinking like, okay, I made an amazing introduction, है ना? वो सब बर्बाद हो गया, ठीक है? Because voice was not there and you didn't listen to what I was doing, and I think you will be like, sir is doing some hand movements and can't understand what he's saying, isn't it? Okay. Anyway, thank you so much. So, if you haven't heard, today we'll be doing the sample paper discussion for the Term 2 examination, which is released by CBSE. And obviously, why it is so important to solve the sample paper? Because it will give us an idea about how the question is going to come, right? What is the examination pattern and what type of questions we should be expecting and practicing for the Term 2 examination. And we can also make a small guess on the weightage of each and every chapter for this particular Term 2 examinations. ठीक है? Okay, yes. Moving on, मेरा बच्चा लोग. Now, if you are seeing me for the very first time, a bit of introduction about myself. I hope you all can see it on the screen, right? I have an experience of more than 3.5 years in the field of teaching JEE, NEET and a board student. I'm a beta graduate from an IIT Calicut, मेरा बच्चा लोग, in mechanical engineering, and here I am. Now, to the very new students who doesn't know at all me, one more thing I have to add is like I'm from Kerala, मेरे बच्चे लोग. I'm not so good with the language of Hindi. ठीक है? I'm improving every day. I'm trying to learn lot many things in Hindi, but I'm still in that improving phase, and I hope everything is sorted out. So we'll be having our discussion completely in English. ठीक है? And I say in all my classes, छोटी छोटी बातें, okay, in the classes में होती रहती है. ठीक है? Fine. Now I'll show you the schedule for this particular week, bachalo, and let's see how are we going to make the preparations for term 2 in the best way possible. Dekh le everyone. Now we have our next class on Wednesday at 8 p.m. on wave optics, so don't miss it. We'll be discussing NCERT exercises, example question, some MCQ questions, don't miss it. And wave optics, Anna, we already have completed the chapter by 8 p.m. today, so we'll be having one complete revision. That is so much necessary, right? We'll be going through all the concepts of this particular chapter of wave optics. On this Friday, it'll be like a one-shot video where we'll be completing the revision in 1 hour. So this is very much necessary. You can make use of the session to make your short notes also. ठीक है? Okay. Now, बच्चा लोग, if you don't want to miss the live classes from your favorite teachers, Telegram link is given here and also in the description box. Bucks Bounty क्या होता है? It's an amazing program to help you get a lot much of prizes. What do you have to do? You just have to go to the description. ठीक है? They will find a link, fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारा prizes मिल जाएगा. ठीक है? बच्चा लोग, tell me, anyone who haven't enrolled for this Combat scholarship test? Now let me inform you, let me warn you guys, you are missing a lot much of gifts and lot much of scholarship, lot much of things. So don't do it. So jaldi se jaldi come and enroll for it, because I'll just right now tell you what are the benefits you're gonna get once you're a part of this scholarship test. Shall we start from the beginning? Say, okay, just dream that you are one among the first 3 rankers. What are you gonna get? You're gonna get the gold medal for the first, second rank silver medal, and the third rank bronze medal. I haven't completed. For the first 3 ranks, you will be given 1 year of Unacademy free subscription platform. Wow! And others scholarships are given, mere bachcha log. And for the first 25 rankers, certificates are also being distributed. And one more thing, just like icing on the cake, it's just like registration is completely free, mere bachcha. You don't have to pay anything, okay, for this exam. You just need to pay 0 and you are going to get a lot much of things in return. So don't miss this opportunity. But if you want to get enrolled for free, you'll have to do a small task. Do you know what it is? It's not a task, it's actually a sharing of love. So you can use this code of AMB10 and get enrolled into this Combat scholarship test for free. ठीक है? Okay. Now, before we start with our subscription platform ka explanation, I'll just ask one thing. But chalo, just share the class to everyone. So to all your friends, to all your colleagues, and tell them that Bhaiya has started the classes already and ask them to join. Jaldi se jaldi. Okay. Okay, Coco, Sahel. Who else we have? Jia. Okay. So everyone just share the class to all your sweet, amazing friends and just tell them this. Okay. And ask them to join right now. In the meanwhile, by the time they join, okay, I'll give you a brief tour on Unacademy Plus subscription features. Okay, they click. You all know that, or we all know that we are learning nowadays a lot through YouTube, right? Because we have so many amazing educators, so many awesome contents, okay? But there are some students who would love, let's say, a personal mentoring or personal guidance directly from the teachers. Matlab, they'll feel so good when the teacher is always with them to tell their mistakes and to appreciate them whenever they do something good. This can happen, okay? That student teacher bonding can only happen once you're a part of this Unacademy Plus subscription platform, because in the platform there is live chats, okay, question boxes, tabs where you can post your doubts and get it cleared. And more than that, if your doubts are still not cleared, there is a feature called as in-class calling app. Matlab, you can call your educator in the class itself, ask your doubt, get it cleared. Isn't it something awesome that can make you feel that you are actually in an offline class? You can talk with your educator. Matlab, all your doubts will also be cleared, which means learning something with zero doubt, that is a policy of Unacademy Plus subscription platform. Then we have top educators of the country to teach you. Now, because of their huge experience, they'll be telling you what to study, what all examination pattern you should be expecting, what all questions you should be practicing. So if you just follow them, obviously you're going to ace in all the competitive examination you're going to write. And more than that, yes, you'll be ending up in the colleges you are dreaming about. Or kya fir? Study material, practice test, live test series. Everything is being designed in such a way to make you feel more confident and you can learn the best way possible for you. Now, if you're going for 12 months, it will cost you 1,250 per month. Okay, and if you don't want to pay that much, and if you still need so much of discount, this is a code AMB10. Use this, get 10% of discount and maximum offers while you make the subscription. Okay, moving on, we have one more kind of subscription called as Iconic. Okay, ye kya hota hai? And in Iconic, you'll get all the features of Plus. Plus some extra features will also be there, such as देख ले personal mentor, मतलब a person will be assigned to you. He'll be telling you what to study, what not to study. For every academic activities, this person will be there along with you. ठीक है? Then live doubt solving classes, weekly reports, सब कुछ, okay, just to make you feel good and to feel more secure and to get so much of marks in all the examinations. देख ले, if you go for 12 months, it will cost you 2,333 per month. And we have our code also, AMB10. Use this, get 10% of discount and maximum offers while you make the subscription. ठीक है? Okay, done. Now this is the best time for you all to make the subscription, because if you go for 12 months, extra 3 months is given, and this is valid only for first 500 subscribers. Code mat bhulna hamara AMB10. ठीक है? Now, bacha log, wave optics, we have a class on this Thursday at 4:30 p.m. We'll be discussing NCERT exercise and examiner part 2. Part 1 is done on YouTube. Part 2 is being done here. Okay, in the special class, you can join. This is completely free. And the code for joining this class for free is AMB10. It's free. Special class. Okay? It's free. Expecting every one of you to enroll for it. Okay, now it's time for the discussion of the questions. So tell me, are you all ready? Ready hai kya? Sahil, Shraddha, Abhishek, Jia. Yes. Hi Sana. Hello. अरे हिंदी तो मुझे पता नहीं, ठीक है, मुझे थोड़ा ही पता है. I'm learning. So how can I explain the things in Hindi? Ready everyone? Jia, Evelyn, Shraddha. Okay, so here we go. We'll start from the first question. Initial questions are simple actually. ठीक है? देख ले. In a pure semiconductor crystal of silicon, if antimony is a pentavalent, matlab 5 valence electrons, isn't it? Yes. So antimony has a 5 valence electron is added. Then what type of extrinsic semiconductor is obtained? Tell me, if we add an impurity with 5 valence electron, what kind of impurity we get? Sorry, what kind of semiconductor we get? We get N-type semiconductor, isn't it? Yes. Okay. Now, draw the energy band diagram of this extrinsic semiconductor so far. So, in energy band diagram, we'll be having two things to be shown. One is valence band, the other one is conduction band, and the energy gap between them, we call it as forbidden energy gap. Now, as it is an n-type semiconductor, we'll be having so many electrons as the charge carriers. So, in the valence, opposite, क्या कर रहा है मैं क्या कर रहा है सर आप ये तो conduction band है ये तो valence band है ठीक है. In the conduction band, as we are doping it with a pentavalent impurity, the majority charge carriers will be electrons, and we'll be having so many electrons in the conduction band and a less number of holes in the valence band. ठीक है? And obviously there will be an extra energy level which we call it as E donor. Okay, what is this extra energy level? This is the extra energy level of the impurity that you add to this semiconductor or to this silicon pure semiconductor. Okay, so this is how the energy band diagram is going to look like for an extrinsic semiconductor of n type. ठीक है, clear है ना? And obviously ये तो simple भी है, उतना तो difficult भी नहीं है, isn't it? Okay, clear? Okay, clear, right? I don't know, many of you might not be clear about this particular part because in many classes, even I also haven't read the chapter of electronics, but sample paper is being released, so we'll be discussing the questions. That's all we are doing. Okay. Next question. So everyone try to do the question. Okay, cool. अरे सुदीप देख ले, सना is here with full of activeness. हाँ और क्या, अरे we'll be having the subjective exams, right? So we have to make. Okay, so I think we can go for the next question. So everybody start reading our next question. How it is? Consider two different hydrogen atoms. The electron in each atom is an excited state. Is it possible for the electrons to have different energies but same orbital angular momentum according to the Bohr model? How many of you have learned the chapter of atoms from modern physics, let's say? I think it will be very less, right? Okay. Anyway, I'll help you to understand how this question can be done and try to understand in the best way possible because many of you this chapter might not have done it. Okay? So don't worry, I'll explain in detail about the concept when the chapter is done. For the time being, we'll discuss the question. देख ले, we have two hydrogen atom. अरे ये तो क्या है? हमको ये तो नहीं चाहिए. Okay, so we have two hydrogen atom. This is a nucleus, let's say, and in the first hydrogen atom, the electron is in an let's call it in an excited state of N1. Okay, and in the second hydrogen atom, the electron is in an excited energy state of N2. Question says, is it possible for it to have same angular momentum and different energies? So first, let us write down the formulas for angular momentum. What is the formula for angular momentum? It should be an integral multiple of h by 2 pi. So as the electron is in an n1 orbit, angular momentum will be equal to n1 h divided by 2 pi. So what about the angular momentum here? L2 is equal to n2 h divided by 2 pi. It says to have same angular momentum. If the angular momentum L1 is equal to L2, then n1 h by 2 pi will be equal to n2 h divided by 2 pi. है ना? I just have equated the values of L1 and L2. h by 2 pi will cancel, which says n1 equal to L2. मतलब, if their angular momentums are same, both of them should be spinning or orbiting in the same orbit. Now, let us go for the energies. Now, the question is, if they are having same angular momentum, is it possible to have different energies? देख ले, what is the energy here for an electron? Minus 13.6 by n1 square. And what about the energy here? That is minus 13.6 divided by n2 square. अरे देख ले, here n1 value and n2 value are same. अरे if n1 value and n2 value are same, won't E1 be equal to E2? Yes. So what we have just got is, if L1 is equal to L2, the energy of the electrons will also be the same. So is it possible to have different energies? No. The answer is no. Justify your answer. So you have to write all these things down in order to get 2 marks, because section A has 2 marks. Clear ho gaya na? Is it clear? Yes, Sahil, Nikhil, Denny, Shreya, Mohit, Jia, every one of you. Yes, yes, yes. Okay, then let's go for the next question then. Kisko intezar karna hai? Okay, so we have our third question from the section. First one, explain how does the photoelectric current and the kinetic energy of the photoelectrons emitted in a photocell vary. Okay, if the frequency of incident radiation is doubled, matlab frequency f dash is equal to 2 times the initial frequency, but keeping the intensity same, I dash is equal to I. Now, first question, how does photoelectric current changes? We know that there exists a simple relationship between the current, ठीक है, and intensity I. What is it? The simple relationship is that they are proportional to each other. Matlab, if the intensity increases, the electric current will also increases. But here the intensity is kept the same. So if intensity is same, current will also be remaining the same. So we can write, in the first case, current is remaining the same, because it is only dependent upon intensity. Current has no relationship with the frequency here. ठीक है? Now, second question is, what will happen to the kinetic energy? Okay, once the frequency is doubled. Let's write down the formula for kinetic energy. What is it? Kinetic energy is equal to the energy of the incoming light, h times frequency, minus nu naught. What is nu naught? Work function. ठीक है? Now let's see what will happen to the kinetic energy is frequency is doubled. क्या होता है? The new kinetic energy Ke dash is equal to h, instead of f it is 2 times f minus nu naught. ठीक है? देख ले, h 2 times f, okay, or hf we have 2 times hf, isn't it? H into f. What is h into f from here? That is Ke plus phi naught. ठीक है? So Ke plus phi naught, this minus phi naught. So the new kinetic energy Ke dash is equal to 2 times Ke plus 2 phi naught minus phi naught plus phi naught. देख ले, the new kinetic energy Ke dash is twice the kinetic energy plus phi naught. Matlab, once the frequency is being doubled, the kinetic energy will be more than double the value, because Ke dash is not 2 times Ke, it is 2 Ke plus phi naught. This is very important. Okay, one more question is there from this part itself. Show the graphical variation in the above two cases. Matlab, we also have to show the diagram of kinetic energy versus frequency. How is it? Here I am plotting kinetic energy, here frequency. देख ले, until we give a minimum value of frequency, which we call as threshold frequency, the electrons will not be emitted. Matlab, kinetic energy is 0. If the frequency is greater than that, you can see that kinetic energy will be increasing in a linear fashion like this. ठीक है? So this is going to be the graph of kinetic energy versus friction. ठीक है? Clear? Clear? Dene, Nigel, Lakshita, foes of ADC army. Now jaldi se note kar le. I'll just adjust the screen so that you can see the entire thing what I have explained right now. Okay, this is a very important question from the part of dual nature. Clear hai na? Evelyn, Sudeep, Mohit, Sana, Miara, Nikhil. Okay, everyone. Note kiya everyone. Note it down. Noted everyone. Those who haven't noted, jaldi se note kar le. Or take a screenshot, whichever is better for you. And those who are having the habit of always taking click, click, click screenshot, please try to make the short notes. Okay. ठीक है. Bye, Jia. Good night. Okay, so we are proceeding further for the next question. Okay. Name the device which converts the change in intensity of illumination to change in the electric current flowing through it. How many of you know? Ready from the chapter of electronics. It is photodiodes. That device which convert the energy of light into electrical energy is photodiodes. Okay. Now plot IV characteristics of this device for different intensities and state any two applications. Okay. Dekh le, I'm not going for the entire explanation of a photodiode because those who haven't learned the chapter, there is no use, because if I simply go on explaining a photodiode kya hota hai. For the time being, just understand that this is photodiode. Okay. And the IV characteristics will be looking like this. Dekh le. The reason why it is drawn with negative current and negative voltage is because this is connected in the backward biasing, or we call it as reverse biasing. Reverse biasing. Okay, this is for an intensity of I1. Now, if we give more intensity, obviously, the current will also be larger here. Okay, good to go. Fine. Everyone? Okay. Now, when we talk about the applications can be photo detectors, burglar alarms. Okay, if you want some of the applications, photo detectors. Okay, then burglar alarms and all. Fine. Is it clear, everyone? No doubts, I suppose. Okay. Jaldi se note kar liya. I think this was one of the simplest one. Actually, it is a 2-mark question. So don't write much more. Whatever is asked, what is photodiode? Draw the diagram, drawn diagram. ठीक है? Now, if intensity is increased, देख ले, current is increasing, as you can see. Now, some of the uses here. Okay, write this much only, you will get 2 marks. Moving on. Note किया ना सबने? I think only some things to be noted down. Okay, हम जा रहा है to section B. Now, I think many of you stayed this. I have seen the comments from many of the students that this is a question which everybody is finding it so much difficult. Fine. Okay. So anyway, I'll explain this. Try to understand, and you'll understand in a better fashion once this chapter is also over in the class. Okay. Extreme, Shraddha, Sana, Sahil, Denny, founder, Miara, Sharma, Khushbu. Okay. Fine. Let's do this. Dekh le. First one is derive an expression for the frequency of radiation emitted when an hydrogen atom de-excites from a level n to a level of n-1. First we will do this. ठीक है? Then we will read the remaining part of the question because it's a bit confusing. So I'll discuss part by part. Now here we have the nucleus of hydrogen. Okay. Then these are the orbits around it. Initially, the electron is in the nth orbit. Let's call it electron here. And it is jumping from nth orbit to n-1 orbit. The energy of this orbit we call it as En, and this as E-1. Tell me, when an electron jumps from an higher energy orbit to a lower energy orbit, it will be emitting out electromagnetic waves. And the energy of electromagnetic waves will be equal to the difference in energy of the orbit. मतलब When it jumps from higher to lower, it will release an EM wave of energy E equal to what is it? The difference in energy of the orbit. Here it is En and En minus 1. So the difference in energy of the orbit is En minus 1. Okay. Now just tell me, everyone, what is the formula for energy of an nth orbit? Everyone. It is m e raised to 4 then 8 epsilon square h square into 1 by n square. ठीक है? Minus, obviously this comes with a negative sign here. Fine. Okay. Next is what do we have? Minus m e raised to 4 divided by 8 epsilon 0 h square the whole divided by 1 by n minus 1 square. Koi doubts? I have just substituted the formula for the energy of the nth orbit. Okay? Minus of minus will become plus. M e raised to 4 by 8 epsilon 0 h square is common, so you can take it as common. So this is m e raised to 4 the whole divided by 8 epsilon 0 square h square. What is remaining? Minus of minus will become plus 1 by n minus 1 the whole square minus 1 by n square. ठीक है? Cross multiply n square minus n minus 1 the whole square. ठीक है? N minus 1 square का n square cancel. On the numerator, if you do the math, I'm leaving it to you. ठीक है? 2n minus 1 will be having. This is 2n minus 1 the whole divided by n minus 1 the whole square into n square. Here we have m e raised to 4 by 8 epsilon 0 square h square. Any doubt? No, right? Okay. Now let's move up and complete our question. First part is done. Okay. Now, also show that for large values of n, this frequency what we have derived equals to classical frequency of revolution of an electron. What is classical frequency? I'll explain. Now, the equation what we have derived was for energy. What is the formula for energy of an EM wave? H nu. Okay. So nu, which is the frequency, is equal to m e raised to 4 by 8 epsilon 0 square h square, and this h comes h cube. N is very much greater. Okay. The value of n is very much greater than 1. So 2n minus 1 will become 2n. Okay. We'll write it here. N very much greater than 1. So n minus 1 will become n square into n square. This is n raised to 4. So the final answer, देख ले, m e raised to 4 by 8 epsilon 0 h cube 2 divided by n cube. Okay, so we have completed only the first part, and that's the exact reason where every students consider that this is a bit difficult question. There is no other way of solving this. This is the only way. ठीक है? Now, question is, we want to prove that ये frequency है ना, what we have derived just now, is equal to classical frequency of revolution of an electron. ठीक है? We'll do that in the next page. ये क्या आता है? देख ले, this is nucleus, and let's say electron is revolving in the nth orbit like this. Tell me what is the time required to complete one complete revolution. Time is equal to displacement divided by velocity, isn't it? How much displacement it covers if it has a radius of r? 2 pi r divided by velocity. ठीक है? Time period is equal to 1 by frequency. We all know that, isn't it? So frequency f is equal to v divided by 2 pi r. I will have to make so many so many substitutions here. Now we have to substitute for v. How? देख ले. Do you remember the angular momentum, which can be written as mvr, should be equal to nh by 2 pi? the angular moment of an electron in an nth orbit is mvr is equal to nh by 2 pi. From here we will get v value, that is nh divided by 2 pi into m into r, isn't it? So for this v, I'm going to substitute the same here. Dekhle, v is equal to nh divided by 2 pi here, 2 pi here. So it becomes 4 pi square, okay, m r into r square. Is it clear? I know that the derivation is a bit long, okay, but we have to go through, and the people call it this as the longest derivation where no one has expected this is going to come. Okay, you can just have a look at it. Okay, now we can substitute for this r and continue the derivations. Okay, so this is nh divided by 4 pi square m. Okay, now bacha log, we have to substitute for this r square. How much it is going to be? N square h square epsilon 0 divided by pi m e square. This is the value of r, the radius of an nth orbit. Okay, now we have to square it. Okay, now what all happens? Here you have m square to it, m square, it will go to the numerator. E square, the whole square 4, so it will be going up. So here we have m square e raised to 4. Okay, the whole divided by m, can you see the same? This m square by m, one m will be cancelled, so we can write it directly. है ना? Okay. So I'm going to write it as m e raised to 4. Okay. Pi square, this pi square get cancelled. This 4 will be there. Then what is it? और क्या है? देख ले, ये n square, the whole raised to 4, this n. So 4 by 1 n will be cancelled. What we have is n cube. Then what else we have? H square, the whole square, h raised to 4, this h, that becomes h cube. Then epsilon 0, the whole square. So here we have another equation for frequency. Now question is, we are asked to prove this classical frequency of electron to the frequency above. Is it correct? Are they the same? Dekhle, m e raised to 4, 4 h cube epsilon the square n cube. And what we have proved earlier is this. Dekhle, m e raised to 4, 2 by 8 is 4, epsilon square h cube n cube. Yes. So what we have derived as a frequency here and what we have derived in the later are the same, and we have proved that both are one and the same here. समझ में आ गया? समझ में आ गया? Okay. Is it fine? Every one of you just note it down. I'll give you 5 seconds, just take a screenshot, and by writing this down it will take too much of time. Then I'll show you the next page. Is it done? हो गया है ना? ठीक है. Now have a look at this, the second part. Hey Rajiv, Ra, Sneha, Sana, little twisted also, right? Yes, it is a little bit twisted and so much of things to be derived here. Anyway, we did it and I hope you all got it. Jaldi se. Okay. Now let's proceed further, I suppose. Section B, next question. Explain with a proper diagram how an AC signal can be converted into a DC signal with output frequency as double the input frequency using a PN junction diode. Give its important and output waveforms. Do you know what you call this process as? We call this as full wave rectification. Okay. Questions are, we are asked to draw the diagram of this full wave rectification. Okay. We'll start from the beginning. Okay, we have a transformer here. Okay, so it is here we give the input. Okay, let's draw the input wave. So this is input. Okay, we'll draw it here. Secondly, an input wave is given here, okay, in the primary windings, and it is in the secondary windings we take the output. Now let's see from where the outputs are being taken. So here we have a diode, and here we have a diode. Okay, we call this diode as D1 and we call this as D2. Now the outputs are taken, one from here, okay, and the other from the midpoint of the secondary windings. Okay, and this is the output. Okay, and this is a simple circuit for converting an alternating AC into a varying DC. Okay, how it is done? When the first positive cycle is given into the input, what will happen? We all have learned what? Mutual induction. Induction happens and current is induced in the secondary coil, where here we have positive and here we have negative. Okay, if this is positive, this diode will be forward biased or reverse biased. Array will be forward biased, current will be going as say, current will be going in this direction, okay, and we'll be having the output. And the output is given from the diode 1. Why not diode 2? Because diode 2 is reverse biased. It is connected to negative. Okay. Now, the second half of the cycle. Now, when the second half of the cycle passes through the first winding, it will be inducing a voltage in the secondary winding as positive here and negative here. Now, as negative is connected to D1, this is reverse bias, no current goes. Now, positive is connected to diode 2. So this will be forward bias. So current will go in which direction? ऐसे. देख ले, through the resistor the current is going in the same direction. So the next wave will also be positive, and this is produced because of the second diode here. देख ले, we have drawn the diagram. We have drawn the input wala input, okay, input wala AC, and the output wala DC is also obtained. Okay, and this process we call it as full wave rectifiers. Clear मेरा चलो? ठीक है? Clear everyone? Now I hope everything is visible. Okay, question तो इधर है. I was showing you the question and I took some extra space for solving the answer. That's it. Completed, right? Sneha, Sahil, Myara, every one of you? Okay, ठीक है. We'll proceed, right? देख ले. Note, I hope you all have noted down. Okay. अगला question पे जा रहे. अगला question. How long can an electric lamp of 100 watts, मतलब the power of the bulb is 100 watts, be kept glowing by the fusion of 2 kilogram of deuterium? What is it said? We have 2 kilogram of deuterium. समझ में आया? And this 2 kilogram of deuterium is undergoing fusion reaction, where each fusion will be releasing an energy of 3.27 into 10 power 6 electron volt. Okay, how can we convert electron volt to joules? By multiplying it with 1.6 into 10 power minus 19 joules. देख ले, if one fusion reaction of deuterium happens, 1H2, 1H2, what will happen? An energy of this many joules are being released. So question is, right, till what time, till what time an electric bulb which glows with the power of 100 watts can be lit if we are making 2 kilograms of deuterium to fuse? How to solve this? Very simple. देख ले, we know the basic equation for power is equal to energy by time, isn't it? Question is to find out the time available. That is equal to the total available energy that we are giving to this electric lamp, the whole divided by power. Power is something which we know. How much is it? 100. Now we are left to find out this energy. Okay. ठीक है. Fine. Now here देख ले बच्चा लोग. When we have two deuterium molecules, how much will be released? 3.27 into 10 power 6 into 1.6 into 10 power minus 19. This much of energy is being released. So we have to know how many such reactions will happen if we have 2 kilograms. For that we have to know the number of deuteriums available in 2 kilograms. How is it possible? Okay, it's very simple. We know that the number of moles can be found out by given mass, that is 2 kilogram, divided by the gram molecular mass of deuterium. वो कितना? That is equal to 2 grams. Isn't it? देख ले. Mass is 2. So 2 grams, that is 2 into 10 power minus 3. This much number of moles. And in 1 mole, how much is available? That is 6.022 into 10 power 23. So this many deuterium particles are there. Question is, if there is this much of deuterium particles, how much is the energy? How will we find out? Array cross multiply kar le these two. I hope you all know, right? 2 times E is equal to 2 times E is equal to cross multiply this. How much we are going to get? बहुत बड़ी number हो जाएगा. 3.27 into 10 power 6 into 1.6 into 10 power minus 19. Cross multiply this also. 2 by 2 cancel हो जाएगा. 10 power 3 goes up. So 10 power 3 into कितना है? 6.022 6.022 into 10 power 23. Okay, so E, the energy will be equal to divided by 2. ठीक है? So बच्चा लोग जल्दी से कर ले. I know how many of you are super good in this. Okay, so we'll be getting almost a value for energy as 15.75 into 10 power 13. This many joules of energy we can have. Okay. Now when we talk about time, it is 15.75 into 10 power 13, the whole divided by power. Time is equal to energy by power. How much is power? 100. So how much is it? 10 power 13 divided by 100. These many seconds we get. Now the final answer can be in years also. How can we convert seconds to years? It's very simple. 15.75 into 10 power 11, 13 by 100, right? Okay. Now how will we convert a year? That is equal to 60 into 60 into 24 into 360. Okay, I am leaving the math to you. We'll be getting an answer of 4.99 into 10 power 7. Okay. Now if the final answer has to be in years, you can do it accordingly. Is it fine? I'll just resize the screen so that you can see the entire question and the answer together. आ गया? Yes, Miara, too much calculative, and you just have I think you all had a look at how was the previous derivation also. वो भी बहुत बढ़िया था, isn't it? Clear? Sahil, Sneha, Miara, everyone, कोई भी doubt है तो पूछ ले बच्चा लोग. If you have any doubts, please let me know, or else we can go for the next question. Is it fine? Yes, very good question to confuse us. ठीक है, बहुत बढ़िया तो था. Everyone is so amazed at the level of the questions, I suppose, isn't it? Okay, let's go for the section B. Another question. Define wavefront array. ये सब हम तो कर दिए है ना. But chalo, wave optics chapter we have completed. What is wavefront? It is a locus of all points which is vibrating in the same phase. Okay. Now draw the shape of a refracted wavefront when the plane incident wave undergoes refraction from optically denser medium to a rarer medium, hence provides Snell's law of refraction. अरे ये तो simple है, we have done in our classes. We can draw this, right? देख ले, this is the line of separation. This is the first medium refractive index N1 with refractive index N2. We are having an incident wavefront here. I'm considering two light rays, one light ray here and another light ray ऐसे, ठीक है? Okay, ये तो normal होता है, isn't it? Now tell me, this particular ray of light, let's say it take a time of t for it to reach, move from here to this particular point. So if I mark this as B and C and this is A, how much will be this BC distance as? That is equal to the velocity with which it travels V1 into T, isn't it? Now it is traveling from denser medium to rarer medium. So this light ray will be entering into the second medium, and how much will it travel? And it will be traveling a distance of, velocity will be V2 in the second medium into T. This is angle of incidence I and this is angle of refraction R. Now how can we draw a refracted wavefront? Very simple. Wavefronts, this is a refracted light ray. Wavefronts are always perpendicular to the ray of light. Okay? This is a refracted ray of light. This is the refracted wavefront. Okay, how we got that this is the refracted wavefront? By using the simple concept that the ray of light is perpendicular to the wavefront here. Okay, now we have to prove Snell's law. This is I, this is 90 minus I, so this is once again I. Okay, ये तो R है, ये तो 90 minus R है, देख ले ये 90 है, ये तो triangle है, A, C, D call it, ये 90 है, ये तो 90 minus R है, ये तो R है. Isn't it? ठीक है. Now let's do sin I by sin R. Sin I divided by sin R is equal to, what is sin I? Opposite, that is BC, which is equal to V1T, the whole divided by AC. I'm not writing it because it is going to get cancelled. Sin R is equal to AD, that is V2T. Okay, V2T, the whole divided by hypotenuse, that is AC. AC on the numerator and denominator will get cancelled. I'm not writing it separately. So TT will also get cancelled. We have V1 by V2. I'm multiplying C on the numerator and C on the denominator. ठीक है, ये C by V2 क्या आता है? अरे N2 होता है. ठीक है, ये V1 I am taking it to the denominator of the other C. C by V1 is N1. N2 by N1. What is it? Sin I by sin R. देख ले कितने आसानी से we have got the answer for this. There are some good questions, simple questions, direct questions which we can answer within some seconds. But there are some questions which are so tough and it will take some time for us to solve. Okay. अरे बच्चा लोग, अरे बच्चा लोग, ठीक है. Sir, please help me, which will be beneficial in BSc Physics? Physics or computer? It's up to you. Whichever you feel good, whichever subject you want to learn, it's up to you. Go for it. Okay? Listen to what your heart says. Nothing like beneficial. If you follow your dreams and heart, it will take you to the right place always. Okay? Complicated, but Miara, we have actually solved this problem in the classroom. Actually, we have solved this. ठीक है, हो गया. I hope you all have noted this down. कोई भी डाउट है तो जल्दी बता. ठीक है भैया सना. बढ़िया बात है सना. ठीक है. So let's proceed and solve the next question, what is waiting for us? Okay. What is our next question says? Draw a row diagram of a compound microscope for the final image formed at least distance of distinct vision. Shall we draw the compound microscope ka diagram where the image is formed at least distance? Okay, fine. So it's a microscope. So we have an objective lens, let's call it. Okay, and also we have an eyepiece. Okay, so let's call this as a common principal axis as we have it here. Now, if we keep an object here in front of the objective lens, one of the light ray will be coming. Okay, and you can see that an image is formed here. Okay, this is the object of the objective lens. This is the image of the objective lens, and the light rays from this image is actually reaching the eyepiece. Can you see that? Dekh le. Yes or no? So the image of the objective lens will be actually acting as the object for the eyepiece. Yes or no? Because it is from this particular image the light rays are reaching the eyepiece. So to the eyepiece, this will be the object. ठीक है? Now you देख ले, refraction happens, and here it is not going to be meeting at any point because it is diverging. So if you extrapolate, you can see that it will be meeting on the same side of the object, which will be at a distance of 25 centimeter, which is called as the least distance of distinct vision. So this is a simple diagram. ठीक है? It is a simple diagram directly from NCERT. So nothing new is here to be learned. Is it fine? Just have a look at it, and it's the same diagram. Okay, so it's okay, I got it. If you go to resolve and solve, that's why. Okay, this is not MCQ question this time, as you all know. This time the term 2 is going to be completely subjective, and they'll make it a bit tough. You just look at the level of the question they have had here. So I hope you can understand that something big is going to come. So be prepared. Okay. So anyway, let's proceed further. We'll go for the B part of the question. What is it? An angular magnification of 30x is desired using an objective of focal length 1.25 and an eyepiece of 5 centimeter. How will you set up the compound microscope for the final image formed at least distance of distinct vision? Now we'll do this in next page. Okay, we'll write what all things are given. Focal length of objective is 1.25 centimeter. Focal length of eyepiece is 5 centimeter and magnification is 30 actually. Question is, how can we construct this compound microscope if the final image to the eyepiece is formed at least distance of distinct vision, which is 25 centimeter with a negative sign. ठीक है? Now, how can we solve this problem, or what is actually asked? The question that is asked is to find out the length of this compound microscope. Tell me what is the length of the compound microscope. देख ले. From here to here it is V0. From here to here it is UE. So this is V0, this is UE. So V0 plus UE is the length, and that's asked to be found. Now the reason for expressing this D as minus 25, देख ले, we measure this 25 towards left direction. That's why minus. No doubts, I suppose. Okay. Now starts writing down the formula. Magnification M is equal to V0 divided by U0 into 1 plus D by F. The direct formula. Magnification, it's 30. Positive 30 or minus 30. Dekh le. Object is like this and the final image is inverted. So magnification is negative. ठीक है. So minus 30. That is equal to V0 by U0, which we don't know. 1 plus D is 25. Focal length of eyepiece is 5. कोई भी doubts? No, right? 25 by 5 is 5 plus 1, 6. 30 by 6, Yes, 6 and once it comes to the left hand side goes as the denominator. 30 by 6 is 5. So minus 5 is equal to V naught by U naught. So V naught is equal to minus 5 U naught. So we are asked to find out length, which we already have told it is V naught plus UV. First thing what we need is V naught. How can we find? Array by using the lens formula of the objective lens formula. 1 by V naught minus 1 by U naught is equal to 1 by M naught. 1 by V naught minus 5 U naught. Okay, minus 1 by U naught is equal to 1 by focal length of objective is 1.25, or let's call it as 5 by 4. 1.25 is 5 by 4 by 4. I'm multiplying 5 here to have a common denominator. So this is minus 6 by 5 U naught is equal to 4 by 5. 5 cancels. U naught is equal to 6 by 4 minus 3 by 2 or minus 1 by 5. And what about V naught? V naught is equal to minus of U naught. So minus of U naught is equal to minus 1 by 5 into 5 times. So how much is this going to be? 7. So we got V naught as how much? 7.5. So just have a look at it, what all things we have done here, and any doubt if you have, let me know. Any doubts if you have? कोई भी doubt है तो बता दे. I hope you understood what we have done. We already have completed this chapter of ray optics also. Yes, sir, CBSE is taking revenge. I don't want to comment about it, but the toughness of the question is very hard. It's so tough actually. Okay, shall I proceed further? Now, what is left to be found out, bacha log? V naught is already there. UE we have to find out. Okay. The final image is formed at least distance of distinguishing. So VE value minus 25 is given. So I'm going to write the lens formula for eyepiece. That is 1 by VE minus 1 by UE is equal to 1 by FE. 1 by VE is equal to minus 25 minus 1 by U naught is equal to 1 by 5. Okay, continuing. Minus 1 by U naught, if you take to the right 1 by U naught, okay, minus 1 by 25. This is minus 1 by 5. Making it common denominator by multiplying it with 5. 5 here, 5 is 25. Minus 1 minus 4 minus 6 divided by 25 is equal to 1 by U naught. So U naught is equal to 25 by 6 with a negative sign. 25, this is minus 4.17 U naught. So how much is length gonna come? Length is equal to V naught, okay, plus UE. It is UE, right? UE, E. Array E tha here. E. Just replace O with he here. Okay. Eyepiece we are talking about. Here it was objective, there it was eyepiece. So it's E. So UE. So length is V naught, that is 7.5 plus UE. So this is 11.67, right? 7.5 plus 4.7, don't need to consider the negative sign while calculating the length. 7.5 plus 4.17 length. 7.5 plus 4.17, this is 11.67. And that's our final answer. Okay, I know it's tough, it's big actually. Okay, and I think it has to be tough. I have no idea. I don't know what to comment on this. So have a look at it and note down everything. Okay. Quite messy. Arey, it's easy only, but the questions are really tough this time. That's what I can say. Okay. Everyone, is it clear, I suppose? Sub clear? Achhe se? Okay. Anyway, we'll go for the next one. Next question we have. Okay. So draw a ray diagram of astronomical telescope for the final image formed at infinity. We can do that. So telescope, we have an eyepiece. We'll draw bigger one, right? Or let's take a fresh page. Dekh le. We have an objective here, and we have an eyepiece here. Now light rays, as it is telescope, it will be coming from infinity. One of the light ray, let it pass through the optical center. It will go like this, and the other one bends, and obviously it will be meeting at the focal plane of objective, right? Yes or no? Yes. Now I think we can draw this a bit more clear, right? Question is, sorry, picture is not looking good, I say. Okay, देख ले, we'll draw a better picture. So ये हमारा ऑब्जेक्टिव है, ठीक है, ये हमारा eyepiece है. This is our principal axis. One of the light ray comes, ठीक है, another light ray comes, and it will be bending, it will be meeting. We'll have the first image, which is the image of the objective, and where it will be formed? Obviously at the focal length of the objective, because light rays from infinity will be converging in the focal plane. Okay, I'm drawing this a bit bigger. Last time also I tried to do, but it was not happening. These light rays are, I'm just making a small change here, I say. Okay, it will be passing through the second one, and it will be undergoing a refraction, and you will see that the light rays are never meeting anywhere. Matlab, the image is formed at infinity. Now, this length is obviously the focal length of eyepiece. Okay. Now, this is the case of the image formed at infinity in the case of a telescope, as you can see it here. Okay. Fine. Now, questions are left for us. Let's do the mathematics also here. A small telescope has an objective lens of focal length 140 and an eyepiece of focal length 5. Find the magnifying power if the telescope is in normal adjustment. What is the formula for focal length? F0 by Fe, that is equal to 140 divided by 5 centimeter, which is 28. Okay. So magnification in the first case is F0 divided by Fe. What about the second one? The final image is formed at the least distance of distinction. In that case, what's the formula for focal magnification? Magnification is F0 divided by Fe into 1 plus Fe by D. This part is just the inverse, because in microscope it is D by Fe. Here it is Fe by D. Please do take care of it. Okay. So F0 by Fe, how much is it? 28 into 1 plus Fe, focal length of the eyepiece, it's 5, divided by D is 25, right? 5 by 25 is 1 by 5. So 1 by 5 plus 1. So 5 plus 1, 6. 1 plus 1 by 5, 5 plus 1, 6, divided by 5. Okay. So how much we can expect an answer here? Almost like 33, 32, right? So almost we can say 33 point something it is going to come. Okay, 33, 28, 6, okay. 33.6 we can expect. Okay. Now, I hope you got it. Is it clear? Okay, this question was actually easy. Okay, the ray diagram you have to by heart it. I hope the questions are not going to come this tough. Let's hope so. Okay, you can just note it down everything. Jaldi se फटाफट. हो गया? Once it is done, let me know. हो गया, I suppose. Right? Okay. Now we can jump for the 9th question here. Okay. Light of wavelength 2000 Armstrong falls on a metal surface of work function 4.2. I think it's a question from, not I think, it's a question from photoelectric effect. First thing, what is the kinetic energy in electrons? Just tell me the formula for kinetic energy. That is h nu divided by work function. Okay? H nu is frequency, that is velocity divided by wavelength minus phi naught. Now, phi naught is given in electron volt. So, if we put the value of h, which is Planck constant, 6.6 into 10 power minus 34, 3 into 10 power 8 divided by wavelength in meters, we'll get the energy in joules. If you want to convert this joule into electron volt, divide by 1.6 into 10 power minus 19 kar le. Now, the final answer that you get is 12400 divided by wavelength in Armstrong. You can by heart this. Okay? Whenever you want to find out that the energy in electron volt, where the wavelength is in Armstrong, the simple formula is 12400 by lambda, so that you don't have to do all the substitution. Okay? The calculation will also be easier here. Lambda का value कितना दे दिया है? 2000 Armstrong. ठीक है? So substitute कर ले. 12400 divided by how much is it? How much it was? 2000, I suppose, right? 2000 minus 4.2. ठीक है? 0 is 12.4, 6.2 minus 4.2, that is a 2 electron volt. The answer for the first question. देख ले, simple है. Okay, now let's go for the B part. What will be the change in energy of the emitted electrons if the intensity of the light is doubled? देख ले, in the kinetic energy, nowhere the intensity term is coming. So if intensity is doubled or tripled or whatever happens, no change in kinetic energy. ठीक है? We can write it here itself, no change. Fine. Now, third part. If the same light falls on another surface of on the same surface, okay, another surface, same light falls on another surface where the work function is 6.5, what will be the energy of emitted electron? We know the simple relationship. What is it? The energy of the incident light h nu should be greater than work function phi naught for the electrons to get emitted. Okay? What is the energy h nu of the incoming light rays? It is 6.2. देख ले, h nu hc by lambda, and we got it as 6.2. Declare. Now, for the second case, for the new metal, work function is 6.5. Is 6.2 greater than 6.5? No. Matlab, the condition itself is not being satisfied for the electrons to get emitted. So, will the electrons get emitted? No. So, we can simply write no electrons emitted, because the work function is larger than the incoming incident light. हो गया समझ? अरे ये तो सिंपल सा छोटू सा क्वेश्चन है ना, इसमें शॉर्टकट क्यों? Are you asking about the previous questions, Sneha? हो गया ये? अरे ये तो छोटू सा मोटू सा नन्ना सा मुन्ना सा क्वेश्चन है. Right? Okay. So I don't find anyone so much active here in this chat box. So I think I'll just continue with the questions here. The focal length of a convex lens made of refractive index 1.5 is 20 centimeter. Matlab, we have the convex lens of refractive index, let's call as N2, is 1.5. Initially it will be kept in air where refractive index is 1. The focal length is 20. What means focal length when it is placed in a medium of refractive index 1.25? Positive or negative? What does it signify? Okay. Now first let us find out the focal length once it is kept in another medium. Before that, let's make an equation for this case. Okay. So the formula for focal length 1 by f is equal to n2 by n1, that is 1.5 by 1 minus 1 by r1 minus 1 by r2. Okay. What is 1.5 minus 1? 0.5, which is 1 by 2, and f ka value bhi de diya hai 20. So 1 by 20 is equal to 1 by 2 into 1 by r1 minus 1 by r2. From here, can I get 1 by r1 minus 1 by r2 ka value? 220 cancel, this is 110. So 1 by r1 minus 1 by r2 is 1 by 10. मिल गया इधर तक? Simple सा, सीधा सा. Okay. Now moving further, the same lens of refractive index N2 of 1.5 is kept in a medium of 1.25. Question is, what is the focal length in this case? Write down the same formula. 1 by focal length is N2 by N1, 1.5 by 1.25 minus 1 into 1 by R1 minus 1 by R. So 1.5 minus 1.25 is 0.25 by 1.25. 1 by R1 minus 1 by R2 is 1 by 10. Okay. So doing the math, you will get this focal length as 50 centimeter. Clear? This is not at all a big problem. है ना? ये तो छोटू questions है. And I also did this kind of a question here in my class. So not so big. Sudeep, super active. Myara is there to support you. Sudeep, good to have such a friend, है ना? My channel remains 24/7 active. Clear? Okay. Moving for the second last one, 11th question, and 12th question is actually case study. Anyway, name the EM waves which are suitable for radar system used in aircraft navigation. So it is actually microwaves. Okay. Microwaves. And I have no idea why the range of frequency of these waves, all these things are being asked right there. I don't usually find these kind of questions to be asked. Anyway, it is written. Okay. The frequency range for microwaves is 108 to 1011 Hertz. Okay. Second part, if the Earth did not have atmosphere, would its average surface temperature be higher or lower than what it is? Now explain. Now, if there is no atmosphere, okay, there won't be any greenhouse gases. It is a greenhouse gases which traps the reflected heat radiation and it will be reflected back into the surface of the Earth itself. Okay? So if atmosphere is there, greenhouses are not there. So if greenhouses are not there, it will not be absorbing and reflecting the heat radiation back to the surface. Matlab, the heat rays will be escaping into the vacuum. So if heat radiation escape into the vacuum from the surface of the Earth, the temperature will decrease. So temperature will be lower. Okay, then an EM wave exerts pressure on the surface on which it is incident. Justify. Yes, because in the dual nature we have learned that the EM waves or any waves can be having its particle nature. Okay? And obviously if a wave can have a particle nature, a particle can exert some momentum and it is possible. And what is the formula for this momentum? It is U by C. U is the velocity of light, which is 3 into 10 power 8, and U is the energy received by an area in a time t by this EM waves. ठीक है, momentum is given by the formula of U by C. You can find this equation from directly from which chapter? Directly from EM waves का part. Okay. Okay, so हो गया. So last part of the question, मतलब we have the last part. अरे okay, so we have one question from here, then we'll be going to the last question. ठीक है, right, देख ले. If the slits in Young double slit experiment are identical, then the intensity at any point on the screen may vary from 0 to 4 times to the intensity due to a single slit. Justify the above statement through a relevant mathematical expression. देख ले, if the width of the slits are same, the intensity of light coming from both the slits will be same, I naught. Now question is, if that is the case, we have to prove that the intensity of light after interference in the Young's double slit experiment varies from a value of 0 to a 4 I naught. We know that the net intensity I is equal to, during the time of interference, it is I1 plus I2 plus 2 I1 I2 cos phi. Now if I1 and I2 are equal here, so I1 plus I2 is 2 I naught. Okay, 2 root I1 I2 actually it is. To 2 I naught into I naught is I naught into cos phi. 2 I naught you can take it as common, so it is 1 plus cos phi. Isn't it, मेरा बच्चा लोग? 1 plus cos phi is 2 cos square phi by 2. 2 cos square phi by 2. Okay, this is 2 I naught. So 4 I naught cos square phi by 2. ठीक है. Is it fine? Fine. Okay. This is a formula for net intensity. देख ले, if phi, the phase difference is equal to 0, what will be the value of phi? Cos 0 by 2, 0. ठीक है. Cos 0 is 1. Square of it, 1 square is 1 itself. So I will be equal to 4 I naught. Let's say phi is equal to 180. Phi by 2, 180 by 2 is 90. Cos 90 is 0. So I will become 0. देख ले, we just have proved the intensity varies from a value of 0 to 4 I naught. Clear, everyone? Now, draw the intensity distribution as a function of a phase angle when diffraction takes place through coherently illuminated single slit diffraction ka graph is asked between what and what? Between the intensity and the angle. It's very simple. We'll take a fresh page. Okay, and we'll do it. Now we know that theta value is equal to n times lambda by a for dark fringes, where in diffraction, don't get confused with interference. ठीक है, and theta value is equal to n plus half lambda by a for bright. Now the question is to draw the intensity versus theta graph for interference. Now you know that when theta value is 0, matlab when at exactly 0 phase difference, obviously we can have the maximum intensity, isn't it? Now when we put n equal to 1, we'll get theta value as lambda by a. Okay, if we put n equal to 1, we are talking about the first dark fringe, and obviously the first dark fringe is at a theta value of lambda by a on the upper side of bright band, and also at the bottom part of the central bright. I hope you understood. This is a screen. Here we have central bright. Here we have the first dark on top of it and at the bottom also. So this is what I have done. At plus lambda by a and minus lambda by a, we'll be having the dark fringes. Now where we can expect the bright fringe, put n equal to 1 here for the first bright, 1 plus half, 3 by 2 lambda by a. So if this is 3 by 2 lambda by a, and if this is minus 3 by 2 lambda by a, At these 2 points, we can have the next light. We know that the intensity keeps on decreasing. Yes or no? Yes. Now it will be having the maximum intensity, then it goes to the dark, then it goes to the dark. So this pattern will be continued. Fine. Fine. Moving on. Now, the last case study question, which is followed by 5 questions. So we'll go a bit fast. To a distant observer, the light appears to be coming from somewhere below the ground. The observer naturally assumes that light is being reflected from the ground by a pool of water near the tall object. Okay. Such inverted images of distant tall objects cause an optical illusion to the observer. This phenomenon is called as mirage. This type of mirage is especially common in hot deserts. Based on the above facts, answer the below questions. Okay. Now, the light rays coming from this object, now it will be moving from one medium to another medium. So how can we have two different mediums? But look, in hot seasons, right, in summer seasons, this ground will become hot faster. So the layer of air just above that will be so much hot compared to the layer above. So this air, we can say that it is rarer compared to the above denser air. So when light rays are passing from the object, it is almost like passing from denser to rarer medium. So it will be undergoing refraction. It keeps on undergoing refraction until the I value is greater than critical angle. If the incident angle is greater than critical angle, it will be undergoing TIR. What is it? Total internal reflection. Matlab, during this case, we can have refraction and total internal reflection possible here. Okay. We'll go with the first question. Which of the following phenomenon is prominently involved in the formation of mirage in deserts? Which all I just have explained. Total internal reflection and not diffraction. Refraction it is. It's not 4. Refraction and yes, this first one, not diffraction. Okay? First one is our answer. It was diffraction. This is wrong, but chalo. Refraction and total internal reflection. I just have explained you, right? Okay, no doubt in that, I suppose. Okay. A diver at a depth of 12-meter dives into a water, sees the sky in a cone of semi-vertical angle. So question is, what is that angle? I'll help you explain this. This is the surface of water. This is the ground. So here we have a person at a depth of 12 meters. Now, if the person is looking to the outside world, he'll be seeing the outside world in a circular form. But if we consider this, the entire thing, we can consider this as a cone here, right? It will be making an angle of theta here. Question is to find out that angle of theta. Okay, how can we find out? A ray of light going like this will be undergoing refraction and will be passing through the line of separation between the medium. Now, if we mark this as the critical angle, we know that sine of IC is equal to what? Sine of critical angle is equal to 1 by refractive index, right? That is 4 by 3. Okay, so IC is equal to sine inverse of 3 by 4. Array, ye IC and ye theta alternate angles, isn't it? So IC can be represented as theta is equal to sine inverse of 3 by 4. Okay. So which one is our option? Third one is our option. Clear? Done मेरा बच्चा लोग. Okay. Sana head is messed up. I don't expect the questions are gonna be this difficult. Okay, I also agree as your physics educator, okay, who was teaching for the past 2 years. I don't think questions are gonna be coming this difficult. So it is a bit difficult, I suppose, a question paper after seeing. So I don't think questions are gonna be this tough. Okay, so anyway, questions are here. Let's deal with it. Okay, 2, 3 more questions, then we are done. Moving on. Next one. If N1 and N2 are the refractive index of the core and cladding, then which among the following would be a correct? And we know that in optical fiber, the refractive index of the core N1 will be greater than refractive index of the cladding. Core means the inside part and the outside part is cladding. Okay? So N1 greater than N2, option 4 is correct. Isn't it? Because it is a concept which we all have learned right there. Now, moving on. A diamond is immersed in such a liquid which has a refractive index with respect to the air as greater than the refractive index of water. Matlab, refractive index of the liquid is greater than the refractive index of water. Okay. Then the critical angle of diamond liquid interface as compared to critical angle of the diamond water interface. Okay. So initially we have this diamond in liquid. We also have this diamond in water. Okay. So we are asked to compare the critical angles of both the cases. We know sine of critical angle is equal to 1 by refractive index. Okay. So 1 by refractive index of the diamond, right? 1 by refractive index of diamond with respect to liquid. So n of diamond by n of liquid. So n of liquid I'm going to write on the top. Okay. Similarly here sine of critical angle, this is called second case. Let's call this as first case. That is equal to refractive index of water divided by refractive index of diamond. Now we know that NL is greater than NW. Okay. So NL by ND is greater than NW by ND. It is given in the question. NL is greater than. So sine of IC1 greater than sine of IC2. So critical angle in the first case greater than critical angle in the second case, or critical angle in the case of liquid greater than that of water. Okay, the critical angle of diamond liquid, which is the first case, is greater or it is increasing, right? It is larger. So the third one is our correct one. I hope you got it. Okay, so here we have 2 more questions, I suppose. Let's see. Okay, one last question. Shall we go for that last question? Okay, fine. Shall we discuss a very last question? This is also a tough question. No, last one. हो गया हमारा. Last one हो गया तो काम आज का. Okay. The following figure shows a cross section of a light pipe made of a glass fiber of refractive index 1.68. Now the outer covering of the pipe is made up of a material of refractive index 1.44. What is the range of the angles of the incident rays with the axis of the pipe for the following phenomenon to occur? Thoda to. Okay, we'll start from the beginning. We have a ray of light coming. Can you see that? Okay, so this is the angle of incidence. It undergoes refraction, it is r dash, and it reaches here. This is the inside part, and this is the second layer. The inside one is having a refractive index of 1.68. Okay, and the outer covering of the pipe is made up of a material of 1.4. Okay, this is N2, let's call it. Now we know that if the refractive index here has to happen, this I dash should be greater than the critical angle. Okay, so let's find out critical angle. How? Sine of IC is equal to 1 by N1 by N2. N1 by N2. ठीक है, 1 by N1 कितना है? 1.68 and N2 is 1.44. It goes up. So sine of IC is equal to 1.44 divided by 1.68. So IC will be almost coming as 59 degrees. Critical angle. Matlab, this I dash over here should be greater than the critical angle 59. I dash should be greater than I dash should be greater than 59 degree. Okay. Now let's go for this R. देख ले, ये तो I dash है, ये तो 90 है. So this R will be 90 minus I dash. देख ले, I dash has to be greater than 59. Okay, for this total internal reflection to happen. If the value of I dash increases, okay, 90 minus I dash value will be decreasing, isn't it? So R will be having the maximum value, mera bachcha log, when this I dash has the minimum value. What is the minimum value of I dash? 59. ठीक है? So R max is equal to 90 minus 59, which is 31 degree. ठीक है? Now, question is to find out the angle of incidence. How can we do that? Array sin I divided by sin R is equal to N2 divided by N1, right? Okay. So sin I is equal to refractive index of the material कितना था बच्चा लोग? How much was the refractive index? It is 1.68, right? देख ले, 1.68. It is kept in a medium of 1 into sin R, sine of 31. ठीक है, this will almost come around 0.8 something. ठीक है, and so sine of I will almost be coming as 60 degree. The maximum value of I will be 60 degree. So which option we can go? Maximum value is 60 degree. So we can go with the option 2. I greater than 0, lesser than 60. Okay, and that was the last question there, mera bachcha log. ठीक है, the last question from the sample paper. Now just tell me, okay, how do you find this paper? Just tell me, how do you find this paper? Is it good? Sir, एक story सुना दो. अरे somehow I was, you know that I started taking my class from here at what time? 8 o'clock, right? Now what's the time? Just look at your clock. It's 11:30. So don't you think someone has to give me a good story right now? Alright, I'm back. It was like a lot many questions are there. Let's get it done here, right? Prajwal Gurde, yes, it was long before. Yeah, I do remember. So everyone is like, in a sarcastic way, the questions were super, right? The sample paper was super. I can get it. So he was like, I'll give back the paper and run away. Okay, so if they have given this much level, so you can expect to a level like this. This is like almost top-notch level or 100 level. Anyway, let's not extend this class as it is already late. So thank you so much for watching. So go through all the questions. Okay. So try to compare the level of the question. So if you are not to this level, improve your level also. Okay, because you want to get full marks for the exams, right? So बच्चा लोग wave optics का NCERT exercises and examiner का special class आ रहे हैं on this Thursday at 4:30 to 5:30. It's completely free special class. Okay, and you know the code, right? It's AMB10. Use this code and be a part of the special class completely for free, मेरे बच्चे लोग. ठीक है? Now, if you want to make a subscription, this is the best time because for 12-month subscription above, you will get extra 3-month subscription, so don't miss it. Moving on. Now, Unacademy Prodigy program is happening. If you want to win a 20 lakh of a college grant, this is the exam which you want to comment, right? It starts from 23rd of Jan from 10 a.m. onwards, and the scheduled test, their dates and times are given. Along with that, obviously, you want to get a lot much of gifts also here. ठीक है? Okay. Batches for class 12 is what you can see. Special class timetable I have shared. This is the super awesome features you can enjoy once you go with the special classes. So yes, obviously I'll do listen. Okay. Anyway, Sudeep is like next level question. I can wait till 3 a.m. I do have so many works for tomorrow also, so many classes for tomorrow also. I don't want to stay awake till 3 a.m. At least I have to go now. Okay, so anyone, I'll leave right now. So thank you so much. Those who haven't liked the session, just move your cursor and click on that like button, everyone. Okay? And thank you so much for being here and making the class so awesome. Those who haven't subscribed, you all can subscribe to the channel, everyone. Okay, so thank you so much. Dhanyavad. I'm leaving Myara, Sana, Princess, Datha, Sudeep, who all we have? Princess Khushbu. Everyone here, once again, bye-bye, good night. See you all tomorrow with full of energy. Let me go and sleep so that I can restore some of my energy and tomorrow I'll be seeing you. Okay, so bye-bye. Take care.